Hello friends, welcome to the channel All Computations. In today's lecture, we are going to discuss what is meant by union, concatenation and Kleene operation over the alphabet. Sigma is the notation for alphabet. So let us consider we having two alphabets A and B for constructing string as well as language. So by using this A and B, I can go for a language summation star which containing all possible strings made up of use of A and B. Okay, so summation star, this one, summation star is nothing but language, and that language is what? It is nothing but all possible strings made up of use of A and B. Okay, so while using A and B, we are going to perform these operations: union, concatenation and Kleene operation. Actually, in this language, it is having union, concatenation and Kleene. We will be see one by one how it works. So now, if I take the first scenario, if I take string of length 0, then how many possible strings are here? So possible strings equals to 1. 1 strings are possible, and that one is nothing but simply null. Then if I talking about second one, that is string of length 1. So possible strings will be 2. So length 1 means A having length 1, this B having length 1. Then talking about string of length 2, how many strings are possible? Possible strings which will be equals to 4, and that will be nothing but AA, AB, BA and BB. So all these are possibilities, and it will be extended till the infinity, because as it is a language over A and B. Okay, so A and B, whatever the combination of possible combination of A's and B's together, that will be the nothing but strings in the given language. Okay, so these are some examples: string of the length 0, 1, 2 and onwards it will be continued. So let us see language summation star or sigma star will be, this null will be there, A will be there, B will be there, A will be there, AB will be there, BA, BB, then will be go for AAA, then AAB, and onwards it will be up to infinity. So now friends, what is the meaning of these terms? This star is nothing but Kleene operation. Star is nothing but the Kleene operation. Then this comma, you can see these commas are nothing but union. Commas are nothing but union operations, and you can see all these strings, whatever the string is present over here, it having either one symbol or combination of more than one symbol. Okay, so you can see here, if I take this BB, so in this case this BB is made up of use of symbol B with the concatenation. Or in the case of this BA, in the case of BA, this BA is nothing but B dot A. Okay, and this containing the concatenation operation. Okay, so you can see in the case of constructing a regular language over the alphabet summation, we using Kleene operation, union operation and concatenation. Okay, so these are the terminologies which are very useful while constructing finite state automata. Okay, so let us see what is meant by Kleene closure and what is meant by positive closure. Kleene closure is nothing but Kleene star, or that is the notation for representing Kleene operation. So what it actually containing, let us see here. So what is the meaning of this equation? L star, which is equals to n is equals to 0 union tends to infinity L raised to n. So what is the meaning of this? So this one is nothing but union of all possible strings starting from length 0. All possible strings starting from length 0. So you can see here, if I go for L0, so what is the meaning of this L0? L0 will be simply null. Then what is the meaning of L1? L1 will be simply by using, I am consider summation is equals to A comma B. So what will be L1? So L1 will be simply A or B. Then in the case of L2, which will be again AA, AB, BA, BB. Then in the case of L3, it will be AAA, AAB, ABA, BAA, then ABB, BAB, BBA, BBB. That's all. So these are the possible strings with respect to L3. So what is the meaning of this terminology? This one is nothing but Kleene star operation. Kleene star operation which containing all possible strings including null string also. You can see starting from length 0. Okay. Now we are going to discuss what is meant by positive closure which is denoted by unary plus sign. Okay, so what is meant by positive closure? L plus, which is equals to union n is equals to 1 to the infinity n raised to n. So that is nothing but positive closure. Okay, fine. Now, what is the difference between clean closure and positive closure? Previously, I have mentioned L star, which is equals to union n is equals to 0 to infinity L raised to n. So, what is the difference? You can clearly got the idea here. So, if you see, in the case of positive closure, the lower limit, that is, we are going to take the strings from size 1, and in the case of clean closure, we are going to take the strings from size 0. So you can write here what is the relationship between this L plus and L star. So you can write here L star, which is nothing but null union L plus. Okay, so that is the relation between clean star operation and positive closure. Okay, means what? In the case of positive closure, there should not be present null. Okay, so that is the relationship between them. Let us take some examples. Okay, so these are the true language given to you, L1 and L2. L1 containing two strings, joy, sad. L2 containing again two strings, full and less. So we have to perform concatenation operation over here. So how to present concatenation operation? You can see here. L1 concatenate L2 will be simply, you can write here, xy, where x belongs to L1, x belongs to L1, and y will be belongs to L2. Okay, so I am going to concatenate L1 and L2. These are the two languages going to concatenate. It will be the resultant as a xy, where x is belongs to L1 and y is belongs to L2. So the resultant will be L1 dot L2, which will be equals to, see, xy. So I will take here the first string from the L1. So what is that? Joy. And I am going to concatenate with full, joyful. Okay. Then I will take this joy and then second string from the second language, that is a joyless. Okay. Then I will go for second string in the first language, that is sad, sadful, and then sadless. Fine. So that is the result with respect to the concatenation L1, L2. If I go for, let us consider the same example, if I go for L2 concatenate L1, so it will be, what will be the result here? So in this case, the result will be C. Full joy, full sad, then less joy and less sad. So if you observe here, L1 concatenation L2 and L2 concatenation L1, the difference is what? It having different result. Means you can write here L1 concatenate L2 which is not same as L2 concatenate L1. Okay, means it does not follows commutative law. It does not follows commutative law. Concatenation operation does not follows commutative law. Clear? Okay. Now take another example whether we have to check it follows associative law or not. Let us consider summation is equals to AB. Okay, and assume x is equals to AAB, y is equals to ABA, and z is equals to ABAB. So these are the strings from language over summation. These are some strings. Okay. So if I want to perform here, see, if I go for x concatenate y, then what will be the result here? X concatenate y will be AAB, ABA, AAB and ABA. So that will be the result. Then y concatenate x will be ABA, AAB. So you can see here this resultant and this resultant not same. Means what? It does not follows commutative law. Now we have to check whether it follows associative law or not. So see here, we have to check x concatenation y concatenation z, whether it is equals to x concatenation y concatenation z. So what is, we have to solve this bracket first. So what is y concatenation z? Y concatenation z is ABA, ABAB. We have taken this string and this string together over here. Okay. Then we have to concatenate this result with x, means x concatenate in bracket y concatenate z. The result will be AAB. I have taken this string. Okay. AAB, and then this result I have to take over here. So it will be ABA, ABAB. So assume this as a equation number 1. So LHS of 1. LHS of 1. So let us go for RHS. So what is RHS? X concatenate y concatenate z. So what is x concatenate y? So x concatenate y will be, you can see here, A B A B A. Okay, fine. And then I have to take here x concatenate y with z. The result will be, I have to use this A, A, B, A, B, A, and then I have to take this A, B, A, B. So that is the result of, I can mention here, RHS of equation 1. So if you observe RHS of equation 1 and LHS of equation 1, means if you observe this one and this one, both are same. Means what? It follows, I am mentioning here, concatenation follows associative law or associative property. Concatenation follows associative property, but it does not follow commutative property. Fine. Okay, so see this relationship among associative, commutative, idempotent. Okay, so always keep in mind union follows all associative, commutative and idempotent property or laws. In the case of concatenation, concatenation only follows associative. It does not follows commutative as well as idempotent. And in the case of Kleene operation, it does not follows associative, commutative as well as idempotent. So that is the relationship with respect to union, concatenation, Kleene for associative, commutative and idempotent. I hope that you are getting this idea. Let's take some examples. So that is the example. Summation is equals to A comma B, means we having two alphabets A and B, and we have to find out a language L. We have to find out a language L over this condition. So what is the condition? We have to find out the language L such a way that that language L containing some strings, that strings are named as X, and that X should be belongs to AB, means the alphabets used in the X should be from A and B only. Okay, and X having length 4 means what? The size of that string should be exactly equals to 4. So what is the possibilities? So you can see here. So by using AB, I am going for language L. L will be simply C. A. Yes, it having length equals to 4. Then A, B. Then A, B, then A, B, A, A. Then next one is B, A, A, A. Okay. Then next one A, A, B, B, A, 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 B, B, A, B, B, A, A, and so on. It will be up to B, 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 B. Fine. So total 16 strings will be there. 1 6. Total 16 strings will be there, and that will be the language over this given statement. Okay, so that is the simple example. You can go for another example. You are given here summation is equals to AB, X is belongs to AB, number of A's in X equals to 2. So what is the condition here? Number of A's in X equals to 2. You have to find the language. So in this case, I'll be mentioned here, L will be equals to the number of A's, that is the condition, must be equals to 2. So it will be like AA, yes. Then AAB will be there. Then BAA will be there. Then ABA will be there, and so on up to infinity. So that is the language over the given statement. I hope that you are getting this. Now take the another example. Number of A's will be equals to number of B's. Means in the given string, number of A's will be exactly equals to number of B's. So in that case, what will be the possible strings? So you can write here L will be equals to null. Because in this case, you can see with respect to null, null does not having any alphabet, either A or B, means they are having equal number of A's and B's. Then talking about AB, yes, AB is possible. Then BA is also possible. Then A, B, A, B is also possible. Then B, A, B, A is possible. Then A, A, B, B is possible. B, B, A, A is possible, and so on up to the infinity. Number of A's will be equals to number of B's. Okay, so I hope that you will be got this idea with respect to union, concatenation and Kleene operation over the alphabet summation, as well as what is meant by Kleene closure, what is meant by positive closure, what is meant by union, concatenation and Kleene with respect to the associative law, commutative law and idempotent law. Thank you for watching this video. Hopefully you will be enjoying this video. Thank you so much.